Good morning and welcome to our next maths lesson. Now today we're going to continue I should say, looking at equivalent fractions, decimals and percentages. So please pause the video now and copy down the short date and LO into your maths exercise book. Okay, so you should have given yourself enough time to do that, to copy both the date and LO down. And now we're going to start the lesson with a review looking at yesterday, okay? So it says, where should we place each amount on the number line? And we have three values. We have 70%, we have 0.2, and we have 2/5. Number one says, help Ambika and Zach to place the amounts on the number line. And we've given you a little hint here, and the hint says, what is the number line going up in? So we can see the number line starts on 0, and it ends at 1. Let's think about how many jumps the number line has. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So have a think, what must each of those jumps be? If there are 10 jumps and the number line starts at 0 and ends at 1, what must each of those jumps be? So that's the first question. Can you put these amounts on the number line? The second question links definitely to yesterday, and it says, what would all three amounts be as a percentage? And I want you to convert then 2/5 into a percentage and 0.2 into a percentage. So please pause the video now and complete those two questions. So you should have given yourself enough time to complete those two questions. Let's have a look now. So we know, start of all, to begin with, we know the number line starts at 0 and ends at 1. And we also know there are 10 jumps. So the first thing we need to link there is how many or what value would each jump be if after 10 jumps we've gone from 0 to 1. And using our knowledge there, we know that 10 tenths equals 1 whole. So if we start at 0 and we do 10 jumps of 1/10, we will end up getting to 1. Okay, so we now know that the number line goes up in jumps of 1/10. Now we need to look at our actual values. So the first one, let's look at 70%. We know the number line goes up in jumps of 1/10. So let's have a look at how we can plot 70% onto that number line. Now we know that 70% is exactly the same as 70 out of 100. But we know our denominator in our number line is always going to be in tenths, so I can label this with 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10. So I can see that every single amount on that number line has a denominator of 10. So I want to convert my 70/100ths into a fraction which also has a denominator of 10. Now if we think about what we did yesterday and what we did last week, we should remember a saying here, whatever we do to the bottom, we do to the top. Now most of the time, that would involve multiplying. But if we look at the number 100 and we go into 10, we can see the number has got smaller. And therefore, this time we're going to have to divide. And this is where we think 100 divided by what equals 10. If we know our times tables, we know 100 divided by 10 equals 10. And because whatever we do to the bottom, to the denominator, we do to the numerator at the top, we now need to do 70 divided by 10, which would give us 7. So our value of 70% would have to be labelled here. So we've done that one now. Let's look at the next one, 0.2. Now, for people who know their learn by heart facts, they will know that 0.1 is equal to 1/10, and therefore 0.2 is just 2 times that, which is 2/10. So they could straight away then label 0.2 on our number line. If you didn't know that, you should be able to label the ones and the tenths, and there you should still see again here that we have 2 lots of 10, which is 2/10, and again we can then label it there. So we've done 0.2 now. The third value was 2/5. This again links to equivalent fractions. We know that 2/5 is not on our number line because all our number lines going up in with a denominator of 10. So we need to convert our 2/5 to a fraction, to an equivalent fraction, with a denominator of 10. Again, whatever we do to the bottom, we do to the top. 5 to get to 10, we multiply by 2. 3 times the top by 2, which would give us 4/10. And therefore, very quickly, I can label 2/5 on my number line. Question 1 complete. Let's look at the second one then. What would all three amounts be as a percentage? Now, the easiest one to start with here is 0.2, because if we think about what we did yesterday, we learned that to go from any decimal to any percentage, we simply times by 100. So to go from 0.2, which is a decimal, to get to a percent, we need to times by 100. So I have 0.2 and I'm multiplying by 100. Now here we need to remember that time moves forward. There are 2 zeros, so I do 2 jumps. And then I rewrite my number, 0.2, and I complete those 2 jumps. Putting in the new decimal point and getting rid of the old one. This is something that we did last week. So now I can see that 0.2 times by 100 is 20. So 0.2 as a percentage is just 20%. If we think about the work we did yesterday, 2/5, we have 2 options here, but we know we want to get to a denominator of 100. Can I go from 5 to 100? Well, yes, I can. I multiply by 20. Whatever I do to the bottom, I do to the top. Whatever I do to my denominator, I do to my numerator. And 2 multiplied by 20 is 40. Now, 40 out of 100, we should know straight away that percent is the same as out of 100. And therefore, 40 out of 100 is just the same as writing 40%. And therefore, I have completed the second question that we were asked to do. So that links back to what we were doing yesterday. Okay? And remember, every day we try and include some sort of review question at the beginning to help us remind ourselves of what we've done the previous day, because we'll be using that to build forward and to move forward in today's session. So, let's start today's session now. So the question here, and remember, it's all linked to equivalences, but the question here is, which is the odd one out? And you've got to explain the answer. So how can we answer this question, and can we compare all of these easily at the moment? Now, some people say yes, we can compare them straight away, very simply, and some people can do that straight away. But however, some people might find it very difficult, and because there's a lot of random numbers up there, some fractions, some decimals, some percentages, so it makes it quite tricky here. Now, the first thing you've got to realise is it's very difficult to compare fractions, decimals, and percentages when they look the same, when they look like, well, basically when they look different, when some are percentages, when some are decimals, when some are fractions. So we need to then try and get them to be all the same thing, either all be fractions, all be decimals, or all be percentages. So on here, I'm going to look at making them all to be fractions. So the first one I'm going to look at, can we simplify any of these fractions? So I'm going to go along, I'm going to look for a fraction. Is this a fraction? No, it's not. Is this one a fraction? Yes, it is a fraction. So can I simplify it? And remember again, and I've gone through these 4 questions over and over again over these past 2 weeks. First we look to the 10 times table, then we look to the 5 times table, then we look to the 2 times table, and then we look to any other times table. So 2 and 20, do they both go into the 10 times table? 20 does, but 2 doesn't, so we can't do that. Do they both go into the 5 times table? 20 again does, but 2 doesn't. Do they both go into the 2 times table? Well, yes, they do, because they are both even numbers. So I divide my numerator by 2 to get to 1, and I divide my denominator by 2 to get to 10. So now I have simplified that fraction. I'm going to go along. Is this a fraction? No. Is this a fraction? Yes. Can I simplify it? Well, I know I can't simplify it because it's already got a numerator of 1, and we cannot have a decimal in a fraction, so I cannot simplify that anymore. Is this a fraction? No, it's not. Is this a fraction? Yes, it is. Can I simplify it? I look through my questions again. Do both the numerator and the denominator go into the 10 times table? And I can see they do, because 10 times 1 is 10, and 10 times 10 is 100. So now I divide my numerator by 10. 10 divided by 10 is 1. And I divide my denominator by 10. 100 divided by 10 is 10. Again, I have now got to my numerator of 1, so I cannot simplify this fraction anymore. So can we simplify any fractions? Yes, we could, and I've simplified them now. Then, can we convert our decimals into fractions? And this is where, if you know you'll learn by heart facts, this is very, very quick. If you don't, it's a little bit trickier. But we have gone through it. So for people who know they'll learn by heart facts, that's easy. You know 0.1 is just 1/10. However, if you do not know you'll learn by heart facts, you must think back to what we did, where you label your columns. And I can see now that I've got my ones and I've got my tenths. And I can see from 0.1 that I have 0 ones, so I have 0 holes, but I do have one lot here of 1/10. So my value here is 1/10. Again, if you know you'll learn by heart facts, you will know that that is just 100. But if you do not, label the columns. We've got ones, we've got tenths, and we've got hundredths. And I can see here that I've got 0 ones, 0 holes. I've got 0 tenths, but I do have one lot of 100. So as a fraction, 0.01 is just 100. Completed. And finally, can we convert our percentages into fractions and then simplify them? So 10%, I know percent means out of 100. So 10% is the same as 10 out of 100. Then can I simplify? Do they both go into the 10 times table? Yes, they do. 10 divided by 10 is 1. 100 divided by 10 is 10. So now I have got my different fractions. I've got them all written down. This one I didn't need to change because it was already a fraction that I didn't need to simplify. So now I can see I've got 1/10, I've got another 1/10, I've got another 1/10, I've got another 1/10, I've got 1/100th, and I've got 1/10. So which is the odd one out? Well, the odd one out is the 100th. And the reason why it's an odd one out, and this is what I would write down in my book, is I would have circled 0.01, and I would then be explaining 0.01 is the odd one out because its value is 100th. However, the value of the other 5 fractions or values or amounts is 1/10. And there we have answered the question. So I want you to have a go at this question. Which is the odd one out below? And I want you to explain why in your books. And I've put down the questions that I answered to help me. The first one, can we simplify any fractions? The second one, can we convert our decimals to fractions? The third one, can we convert our percentages into fractions and then simplify them? So we've got these different questions on the board. So can you have a go, please, at answering these questions? Please pause the video now. Which is the odd one out? And explain why in your book. Pause the video and have a go. Okay, so you should have given yourselves enough time to complete that question. And now we're going to have a look through. Okay, so the first thing, can we simplify any fractions? So I'm going to look for my fractions. 4/10. Can I simplify 4/10? And again, I need my 4 questions. The 10 times table, 5 times table, 2 times table, and any other times table. So let's have a look then. Do 4 and 10 both go into the 10 times table? Well, 10 does, but 4 doesn't, so I can't divide by 10. Do they both go into the 5 times table? Well, again, 10 does, but 4 doesn't, so I can't do that. Do they both go into the 2 times table? Yes, they do, because they're both even numbers. So I can divide them both by 2 to get to 2/5. Then I check again. Can I simplify them anymore? Do they both go into the 10 times table? No. Do they both go into the 5 times table? No. Do they both go into the 2 times table? No. Do they go into any other times table? No. So I've simplified 4/10 and I've simplified it to 2/5. Then I look to my next fraction and I see, can I simplify it? Do they both go into the 10 times table? No, they don't. Do they both go into the 5 times table? No, they don't. Do they both go into the 2 times table? No, they don't. Do they go into any other times table? No, they don't. So I would keep it as 3/5. We've then got 0.4. We need to write this now. Keep going along, sorry, till we get our next fraction, which is here. Can I simplify 8/20ths? Does the numerator and denominator go into the 10 times table? Well, 20, the denominator does, but the numerator does not. Do they both go into the 5 times table? Again, the denominator does, but the numerator doesn't. Do they both go into the 2 times table? Yes, they do. So I can divide 8 by 2 to get to 4 and 20 by 2 to get to 10. Then I go through my list again. They don't go into the 10 times table. They don't go into the 5 times table. But they do go into the 2 times table. 4 divided by 2 is 2, and 10 divided by 2 is 5. So now I've simplified and got my simplified fraction. Then I go to question number 2. Can we convert our decimals into fractions? So let's have a look. Some people will know that 0.4, and straight away they will see that 0.2 is equal to 1/5, so 0.4 is equal to 2/5. But if we're not sure, we label our columns ones and tenths. So I can see I have 4 lots of tenths. Can I simplify that fraction now? Do they go into the 10 times table? No. 5 times table? No. 2 times table? Yes. 4 divided by 2 is 2, and 10 divided by 2 is 5. So we get the answer 2/5 as our simplified fraction. And then finally, can we convert our percentages into fractions? Well, let's have a go. We know 40% means 40 out of 100. Now if I simplify this, do they both go into the 10 times table? Yes, they do. 40 divided by 10 is 4. 100 divided by 10 is 10. Now I try and simplify it further. Do they both go into the 10 times table? No. Into the 5 times table? No. Into the 2 times table? Yes. 4 divided by 2 is 2, and 10 divided by 2 is 5. So I've simplified it fully here. Now I look across my values. Now I have got 2/5, 3/5, 2/5, 2/5, and 2/5. Okay, so now I'm looking for which one is the odd one out. In other words, which one is different. So I can see that 3/5 is different. And I can put that down as an explanation. So I would circle 3/5 and I would be writing 3/5 is the odd one out because every other value is equal to 2/5. And that would be the answer to our question. So look at a different type of question now. So you're going to need to draw this table in your book. So please pause the video here and copy down this table into your books. And pause the video now and copy this table into your books, please. Right, so you should have had time to copy that table down. And what we are basically doing, if we look at the top one, they always give you an example. 0.5 is equal to 50%, which is equal to 1/2. So we are looking for equivalent fractions, decimals, and percentages. So if we start with the decimal, 0.65, how can we straight away turn it to a percentage? And this is linked to what we did yesterday. We learned that to go from a decimal to a percentage, we times by 100. So 0.65 times by 100 is just 65%. We also learned this week that percent just means out of 100. So therefore, as a fraction, I can write that straight away as 65 out of 100. Now, I should be simplifying that using the 4 questions, which I ask every single time. Do they go into the 10 times table? No. 5 times table? Yes, they do. And I can see that simplifies down to 15, 13, 20ths. Okay, so therefore we can't simplify anymore, so we have got our fraction 13 20ths. Then I look at the next row. This time they've given me the percentage 6%. Well, I know to get from decimal to percentage, I need to times by 100. So to get from percentage to decimal, I need to divide by 100. So this time I've got 6 divided by 100. There is no decimal point in the number 6, so it goes at the end. So there we are. We divide that by 100 and we should get 0.06. And then to go to a fraction, I know that that equals 6 out of 100 because percent means out of 100. And then I follow through my simplifying questions. Do they both go into the 10 times table? No. Do they go into the 5 times table? No. The 2 times table, yes they do. 6 divided by 2 is 3. And 100 divided by 2 is 50. And we have therefore simplified our fraction. What I would like you to do now is I would like you to have a go, please, at completing these 2 rows. Okay? So please have a go at completing these 2 rows. So you are converting 3/10 into a percentage and into a decimal, and you are converting 0.07 into a percentage and into a fraction. Pause the video now to complete those 2 rows, please. Right, so you should have given yourself enough time to complete those 2 rows now. So let's have a look at the answers you should have got. So 3/10 we should know is 30%, because remember, we convert to a denominator of 100. We times the denominator by 10 and the numerator by 10 to get to that, and we know out of 100 equals 30%. We can get straight to a decimal because we know the line means divide. So 3/10 is the same as writing 3 divided by 10. And therefore, the number 3, the decimal point is at the end because we can't see it. We go back 1 jump and we get to 0.3. The next question, to go from a decimal to a percentage, we just times by 100, and therefore 0.077%. And we know the percent means out of 100, so 7% equals 7 over 100. Last type of question we're going to look through. Okay, what fraction, decimal, and percentage is shown on the diagram? So we need to think here. What does the diagram most easily show? A fraction, a decimal, or a percentage? And we start by working that out. Now, whenever there is a shape, whether it be a square, a circle, and we've cut into a mount and it's shaded, always start with a fraction. It is a lot easier. And we looked at this yesterday a little bit. So now we need to figure out how many squares are there all together here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 across, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 down. So altogether, we are out of 100 squares here. Then we count up how many squares are shaded. Well, I can see I've got 10 there, 20, 30, 39 are shaded in. As a decimal then, or we could go straight to a percentage because that's actually easier here because we've got our special denominator out of 100. So therefore, as a percentage, that is just 39%. To get from a percentage to a decimal, we divide by 100. So if I've got 39 and I'm dividing by 100, I know time moves forward, so divide moves back. I have 2 zeros, so I'm going to do 2 jumps. I write down my number 39. I cannot see the decimal point, so the decimal point goes at the end, and I do 2 jumps backwards. My new decimal point, get rid of the old decimal point, and I use my placeholder. So I know as a decimal, it has a value of 0.39. Now it's your turn. I want you to have a go at this one. So it's very similar, but what I want you to do is tell me as a fraction. Then I would write it as a percentage, and then as a decimal. And if you can simplify your fraction, then have a go at that, please. So pause the video now and have a go at doing that. Okay, so you should have given yourself enough time to finish this question. So as a fraction, the first thing we do is count up how many it's out of altogether. There are 100 squares there altogether. How many are shaded in? Now, some of you might have counted it up individually, but if you recognise there are 10, 20, 30, 40. Therefore, as a percentage, because we've got out of 100, we know the percentage is 40%. And to go from percent to a decimal, we divide by 100, and therefore 40 divided by 100 should have given you 0.4. Now, I did ask you to simplify if possible, so you should have noticed that they both go into the 10 times table, so I could have simplified to 4/10, and then I simplified again further. 10 times table they don't go into, the 5 times table they don't go into, the 2 times table they do. 4 divided by 2 is 2, and 10 divided by 2 is 5. Now, either of those is correct, 4/10 is also correct, but the percentages and the decimals, you can only have one value. So, you now need to take a picture of the work that you've just done in your maths book and send that through to your class teacher on Class Dojo, please, so we can see the work that you have completed. You then need to log on to Class Dojo and complete the maths activity which has been set for today. Again, as is the case every day, it links to what we've been doing in this online video session. Please use what we've been doing to help you. If you need to go back and watch the video whilst doing the worksheet, do that. If you need to look in your book to help you with it, do that. Remember, if you are struggling with this, me and Miss Beck are both live on Microsoft Teams from 10:30 until 11 to give you this support with your work that you might need. It's not a problem if you need that support, as long as you log on to that live session. Please log on to Teams at this time if you need that support. If you have completed the work confidently, you've sent in a picture of your work that you've done during this video, you've also submitted your worksheet via Class Dojo, then you do not need to log on to that session. Thank you very much for your hard work again this lesson, and I'll speak to you again tomorrow.